First of all, thanks to UWF for having me here today. Really appreciate the opportunity to talk about our Lake Hancock Outfall Treatment Project. What I'd like to do in my presentation today is, first of all, give you a brief background as to why we're doing this project, and then get into the design of the project, and finally talk a little bit about where we're at with construction of the project. I think most of you are probably aware of where Lake Hancock is at. It's located in central Polk County, north central Polk County. It's bounded by Lakeland to the north and west, Bartow to the south, Winter Haven to the north and east. The lake is about 4,500 acres. It's an extremely shallow lake, only about 4 feet average depth, and water quality on the lake is very poor. It's classified as hypereutrophic, and it's been that way for a number of years. The intent of our project is to construct an outfall treatment system on the south shores of the lake. This will take water that's coming from Lake Hancock, going down Saddle Creek, and eventually entering the Upper Peace River, and improve water quality within the Upper Peace River while protecting water quality in our priority water body, which is Charlotte Harbor. Now, I want to start off with the background of why we're doing this project. I think that's an important place and an important understanding to know when you tackle a project of this size. Back in 1987, the Florida legislature passed the Surface Water Improvement and Management Act. That act basically was in response to degradation that was occurring in Florida surface waters, primarily with regard to water quality. What we were seeing was a lot of these outfalls, both urban, agricultural, suburban, were leading to increased nutrients, like we see today in some cases, and causing undesirable impacts, foul odors, algae blooms, generally poor water quality. So the legislature stepped in and decided to do something about it. The SWIM Act basically established 6 priority water bodies around the state, and within our water management district, Tampa Bay was our priority water body. What our water management did in response to this legislation was we established a surface water improvement and management program that basically put together a bricks and mortar group of engineers, geologists, scientists to work with local stakeholders, including our local municipalities and our former basin boards, in order to develop a list of priority water bodies within our water management district, and then beyond that to develop plans on how we would improve those water bodies. So these are our 10 priority water bodies within the Southwest Florida Water Management District. The Lake Hancock project is right here is Lake Hancock. It's not number 3. That number 3 is actually Banana Lake. But what we're trying to do with our Lake Hancock project is to protect water quality in Charlotte Harbor. It doesn't have a lot of poor water quality in it right now, and we'd like to keep it that way. And what I've got here is a graphic that shows the entire watershed of the Charlotte Harbor watershed. This is basically the Peace River, and this is the Myakka River. These tags right here are water quality indices, and they basically give you an indication of how good the water quality is. It's combining a lot of measurements of water quality into one. But what the intent is to show water quality in the Upper Peace River is poor and improves as you go downstream. Water quality in Charlotte Harbor is good, and it's really based upon total nitrogen and chlorophyll are the 2 primary things we're looking at. The graphic right here indicates why Lake Hancock is a problem. What you see here are basically nitrogen loads coming from coming down the Peace River at gauging stations at Bartow, Fort Meade, Zolfo, and Arcadia, and then the total gauge nitrogen load. And then it shows nitrogen load of the main tributaries coming into the Peace River, such as Charlie, Horse, Joshua, and Shell, the Juanita Canal, and P11. What P11 is our structure P11 that's located right up here, and that is the structure that feeds water from Lake Hancock into the Upper Peace River via Saddle Creek. And you can see by far the greatest load coming down the Peace River is generated from Lake Hancock. Therefore, if we can do a project associated with Lake Hancock, we'd probably have a tremendous impact on water quality in the Upper Peace and lead to our goal of protecting water quality in the Charlotte Harbor area. In water year 2003, what we actually saw is about 6% of the flow coming down the Peace River was generated from Lake Hancock, but about 13% of the nitrogen load was generated from there. So again, we can have a good impact on water quality by implementing a project up in this area. So we went through a feasibility process that took a number of years, working with our governing board and local stakeholders. as well as industry groups, and then went into a design phase. And as we entered our design phase, we established this project goal. And it was presented to our governing board and passed back in February of 2006. Our actual goal for this project is to construct a wetland treatment system to achieve a 27% annual nitrogen load reduction in the Peace River, which equates to about 174,000 pounds of nitrogen reduction per year. With this goal, we predict a water quality index shift from the upper Peace River from poor to fair. We can't bring it all the way to good. We just don't have enough space or enough dollars really to do it. But we can have a dramatic impact. That's a big impact just going from poor to fair. And we also have other project benefits. This area where we're constructing our wetland treatment system is a former wetland area before mining activities occurred. And what we can do is restore it back to a natural wetland system or more natural wetland system. We can also have some water storage benefits in the upper Peace River. I'll talk about this in a minute, but we have a minimum flow and level we're trying to meet on the upper Peace River, trying to keep water levels in the river at a higher level, especially during the dry season. So with this project, we can create a little bit of water storage. And finally, we have recreational benefits. We'll be able to take a piece of property that doesn't have much recreation right now and open it up for recreational benefits when we're all said and done. Now, this is the actual footprint of our outfall treatment system. And as you can see, the footprint was already there in 1970, in the 1970s. This is Lake Hancock right here. This is Saddle Creek that runs down along the western shore of our treatment area and eventually enters the Peace River down here. This is an old clay settling area. We heard about that in the Tin Rock presentation today and in several other places I'm sure you've heard about it. But this clay settling area began operation in the 1950s. It continued operation up until about the 1970s, and then it was essentially full. The clay was a part of the phosphate mining process. As they moved the ore, separated the ore from the clay was deposited here and allowed to desiccate and dry. In the 1970s, they began some reclamation activities out here where the existing berms were all pushed inward and drainage was facilitated down Saddle Creek and into Lake Hancock to try and finish off the drying process. The district acquired this property back in 2003 as a part of our old Florida plantation purchase, and our intention was to construct this outfall treatment system and use the existing topography to our advantage. This is the essential design element of what we're trying to do here on Lake Hancock. Again, Lake Hancock is here to the north, Saddle Creek runs down. This is our existing P11 structure that regulates the amount of flow that comes from Lake Hancock down into Saddle Creek. What this project will do is construct a pump station and inlet channel. We're going to have 3 large pumps, 13,000 gallons per minute, about 30 CFS. Pumps constructed right here. Those pumps will pull water from Lake Hancock and then funnel the water into a splitter box. The splitter box will convey water into cells 1 and 2 through these deep zones. These are deep zones that are established to facilitate moving the water across the whole entire cell so that it can then move southward down the cells. The water would then, we'd establish a vegetated community in here that would be capable of picking up the nitrogen loads that we'd like to see removed from the system. And the water would then enter these deep zone areas and be directed to 3 internal structures. And then the water would move through a final cell for polishing before eventually discharging through a discharge structure and an aeration structure into Saddle Creek. So essentially the water is going here, we're just going to direct it through here. Water will take about 3 to 4 weeks to move through this system. The system has the capability of about 52 CFS up to 60 CFS of water treatment. And what we expect is a total volume of about 25% of the water moving through Saddle Creek will be able to treat with this system. But the most important factor is when water quality is poorest during the dry season, this system will treat 100% of the water that's coming out of Lake Hancock. So we think we'll have the dramatic impact on water quality like we'd like to. Now, just to start rolling into the construction of this project right now, we are under construction. As a part of the design process, this was our cut and fill diagram. This is a very large earthwork project. We have about 1.8 million cubic yards of material to reshape and move around on this property. as well as we have to add about 500,000 cubic yards of material to the berm to be able to build the berms back up to hold the water in. We will be holding about 1 foot of water in the system. That's the ideal operating depth. We think that could get to as high as 1.5 feet at very wet periods and as low as 4 inches. We do expect during the heights of drought periods that this might actually go dry, and that's something I'll talk about in a second. We want to make sure our wetland plants will survive. But the cut and fill diagram is interesting in that it shows the amount of volume of material that needs to be moved. Basically, material from this area will have to be transported up to this area, and these are our finished elevations. We want cell number 2 here to be at 115.5, cell 1 at 117.4, 113.5. So that's what we're trying to achieve through our construction, our earth moving activities. This is our vegetation planning plan for when we finish our earthworks activity. What we intend to do is plant vegetation in strips across the cell to allow that vegetation then to propagate and fill in the entirety of the cell. This will be a management and a maintenance operation in large measure, especially after those plants get in place, to try and keep exotics out and keep our plants, our desired species, moving forward. We're also going to be planting cypress domes in here. And also we're going to take advantage of some of the nicer areas that were existing in those wetland treatment, or in the old settling area, by leaving these remaining tree islands. These were pretty nice habitat to begin with, and we decided to take advantage and leave those as they were. Now our project, we went under construction in October of last year, and so we've been under construction for roughly, I guess, almost, well, 10 months now. And we went out for bid for this project in spring of last year. A low bidder came in, and PCL Construction is actually the firm that's doing our construction for us. They're out of Tampa, but they're a very large construction outfit that's nationwide. In fact, I think they're the 5th largest construction company in the United States. Right now, we're about 50% of cell grading. We finished about 50% of the cell grading. The early onset of the wet season has kind of diminished our efforts. It's very difficult to work in clay settling areas when it's wet out. The internal structures, though, are 90% complete, and this photo is just a picture of one of our internal structures and the conveyance of water between cells. Our pump station and discharge structures are well underway. The pump station is probably halfway done. Much of the heavy-duty work has been done there. The discharge structure is about the same place, about halfway done. Our berm work is about 90% complete. We are having to put in a slurry cutoff wall. We will have to have drainage control. Obviously, we don't want our water leaving our wetland cell area, so we're putting in a slurry wall in order to retain the water inside the cells. And we're presently dredging in our inlet channel in Lake Hancock, and we're about 50% complete there. So you put it all together, and we're about 55% complete with the overall project. So we think we're right on schedule with where we need to be. We're scheduled for completion the fall of next year. I'd actually bump that up to maybe hopefully this time next year. We would like to take advantage of next year's rainy season to try and fill the cells. It's a lot easier to use rain than having to pump all that water right away just to get things established. What we expect, though, is, again, completion hopefully this time next year. We'll then go through a startup period and then an optimization period where we'll be allowing the plants to totally establish themselves. A lot of preventative maintenance to keep the exotics out of there, and we're expecting that will take about 1 to 2 years. So we're hopeful in about 2 years that after startup that we'll be at a point where we can actually see our goal statement met. Now just a few more things about construction I'd like to share with you. This is an aerial photo that shows construction right now. This is looking from west to east, so here's Lake Hancock. And again, you can see the outline of the former clay settling area of which we're taking advantage of their former berms. And you can see there's a lot of new white dirt, sand that's been deposited here. That's part of the buildup of the berms we're trying to do in order to take advantage of the existing berms. You can also see there's a lot of cell grading work that's been completed here. This, again, was back in April. So since that period, they had several more months of dryness, and they've completed a lot of the cell work here and got a good start here. But back when this picture was taken, you can see a lot of the cell grubbing had also taken place. They've gotten all the vegetation cleared out of there. When we started work in there, you know, a clay settling area, you never know what you get in a clay settling area. So they can be very difficult to work in. It can be I think the Tinnerock presentation, they showed you the type of equipment that you had to work with in there. Fortunately, our clay settling area was a little more settled than that. So we've been able to use these tractor combo units, pans, to be able to move most of the material around out there. At any one time, you'll see anywhere from 10 to 18 of these units just simply operating out there, moving dirt from one place to the other, trying to achieve the elevations that we're trying to get to. And what you also see here are haul roads that were put in place. This is essentially to facilitate the movement of material. We used a borrow area over here on our old Florida plantation property to capture the borrow that we needed for the berm, and we hauled it using these haul roads. We knew some of these cells would have to have some import, and so that was part of the process, is use the import for the haul road. This is a close-up of our intake structure and our intake channel. This is Lake Hancock right here, so you're looking basically from north to south. And this is the actual pump station under construction as of July 25th. And you can actually see these three dark parts are the inlet channels where the pump cans will go right on top. So that's where the water will be pumped out. This is our dredge that's operating right now. It's essentially dredging a deeper channel. As I said, Lake Hancock's pretty darn shallow. So we're going to be dredging a deeper channel through here and through this vegetative mat. This is on the southern shore, and there's been tussocks that have accumulated in here over the time. This is a new road we put out there as a part of the construction, but this is just a mishmash of semi-consolidated material that'll have to be removed to create a nice clear channel in order to pump the water, and that'll have to be a reinforced channel to keep that material from continually slumping in. And that's what you see right here is the dredge is a hydraulic operation. Its line is running into our cell one, and that's why the water is in this northern part of the cell. Right now it's there because of the rain too, but they're putting all their dredge material out here, and you can see kind of the island that's been created by the dredge material. This right here is the splitter box, and that will convey water from this cell and over to that cell. And this area right here then will be a deep zone that will convey the water on down across the whole length of the cell. Okay, and then when we're all said and done with our project, this is what we would expect it to look like. This is a very close-up view, but if you can use your imagination to expand across 1,000 acres, this is what we would end up with. These are typical plant species that we've found to work well in this clay substrate we'll be planting in. What we did as a part of this project was essentially construct a mini treatment system inside the existing, what we were going to turn into the treatment system. And that was done really to establish which plant species would thrive the best in that clay substrate we're going to be planting in, and how would they do through extended drought periods, because we would hate to spend this much money and plant plants and find out all of a sudden we don't have enough water to support it. And we found that the clay substrate actually holds water quite well for quite a period of time, and we think that given our worst scenarios of drought conditions, much of this vegetation would survive drought conditions, and we'd be able to just go back to operation with minimal mortality once a rainy season came back in place. You will see some of the areas will have open water in the wetland treatment system, but it's predominantly those areas that are along the edges of the berms where we're trying to diffuse that water across in order for it to flow effectively through the cells. So that's really our Lake Hancock Outfall treatment project in a nutshell. We are very excited about the project. It's probably the closest thing that our water management district has done to South Florida STA. We've never done anything quite on this scale, and it is one of the largest construction projects that we've ever taken on ourselves. So we're looking forward to very good results from it. Again, I appreciate United Waterfowlers for having us here today so we can talk about this a little bit more, and I'd be happy to take any questions that you all would have. Thank you.